Hey guys, welcome to another A Level Maths revision video. Today we're taking a look at some more statistics, chapter 5, probability, some of the more interesting material, okay, so much more exciting than some of the dull chapter 1 to 3. So yeah, let's take a look at what we've got. So this first question here is looking at a Venn diagram. So we're looking at the probabilities, so that's the important fact here, probabilities that a group of students like either pasta or pizza. So part A, we get the right pen colour, asks us to write down the value of x. So if you notice x, that's the intersection of A and B. So how do we do that? Well, is the fact that the probabilities must sum to 1. Remember, for a total probability of an event, that probability is equal to 1. So what we're saying is 0.4 plus 0.3 plus 0.05 plus x is equal to 1. So all we need to do is 1 minus these values here. Okay, if you add them up, then 0.75, so x is equal to 1 minus 0.75, which gives us x equals 0.25 there. Okay, so nice and easy to get us started. Part B here, we just need to determine whether the events of basically liking pasta and liking pizza are independent. So you need to know how to test for independence. So independent if, so it's independent if the intersection of A and B, so the probability of A intersection B, is equal to the probability of A times the probability of B. Okay. If that's true, if that does hold, then they're independent. If it doesn't, then they're not independent. So let's just write down what the probability of A and the probability of B are first. So the probability of A, that's going to be 0.4 plus the x, so 0.25. So that's 0.65 there. The probability of B, that's going to be 0.3 plus 0.25. So 0.55 there. Remember, the probability of A intersection B, that's just where the two circles intersect, so that's just x for this question. So we're saying is 0.25 equal to 0.65 times 0.55. If this is true, then they're independent. If it's not, then they're not independent. So 0.25, work out this product here. And what you get here for this is 0.3575, and obviously 0.25 is not equal to 0.3575, so therefore not independent. Okay, so that's that question done there. This is important. Make sure you know this test for probability, or the independence of probabilities. Second question here, we're going to take a look at a general probability question. So we've got 15 beads in a bag, 7 are red, 3 are blue, and 5 are green. So we're selecting 3 beads at random, and they're replaced. So that's important, the fact that they are replaced. Normally you don't replace them. We want to find the probability that the first and second bead is chosen are red, and the third bead is either blue or green. So, question 1. What we're looking for here is the probability that it's either red, red, blue, so the third one's either blue, or this is red, red, green, or it's green. Okay, I want to work out these probabilities. So what's the probability of being red? Well, the seven red ones in total, and how many beads do we have in total? We have 15. So this is 7 over 15. Again, we replace it, so the next one will also be 7 over 15. And then what's the probability of being blue? Well, there's 3 that are blue, so that's 3 out of 15. Okay. But then let's consider the second case here, red, red, green. So we're going to add 7 over 15 times 7 over 15. And then what's the probability that it's green? Well, so that's 5 out of 15 times 5 over 15. So all you need to do now is work these out on your calculator. What you should get in total is 392 over 3,375 there. Okay. So a pretty standard question. Take your time with it. Make sure you've got the probabilities correct. So 392 over 3,375. Part B, a bit trickier. What we're looking for is that we get 1 red, 1 blue, and 1 green that are chosen. And again, they are replaced. So that will actually make this question easier. And we'll see why in a moment. So what we need to consider is all the different basic combinations we've got here. So I could get the probability of, for example, red, blue, green. Okay, I could get that. But we could also get the probability of red, green, blue. Okay. Now let's consider the blue starting first. So we could have the probability that we get blue, red, green. And again with blue, we could have the probability that it's blue, green, red. Oops, that's supposed to be an R. Blue, green, red. And then we just got another 2. And this is when we start with the green one. So this is probably that it's green, red, blue. Plus the probability that it's green, blue, red. Okay. So then we're all the different combinations we can actually have for this question. So let's just start by working out a couple and see what actually kind of pattern forms here. So the probability that we get red, blue, green, so that's going to be 7 over 15 times blue, which is, what was that? 3 over 15. And then we've got green, which is 5 over 15. Okay, so that's my first one there. The next one, red, green, blue, well, that would just be, again, 7 over 15 times 5 over 15 now, times 3 over 15. And you might be able to notice the pattern here now. Essentially what's going to happen at each point is we're just going to get essentially the same multiplication. Obviously, because the order of multiplication doesn't actually affect the calculation, then this makes this much, much easier. Okay, so this will carry on until we get to the very end. So the pattern here is essentially we've got 6 lots of it. We've got 6 lots of these. So I've got 6 lots of this. 7 times 5 times 3. And if you've got 15 times 15 times 15, that's 15 cubed. Okay. And then all you've got to do is just plug this onto your calculator. So this will give you 630 divided by 3375, which we can simplify if we want to 14 over 75. So the fact that we basically do replace it makes that second part a bit easier due to the nature that obviously commutative multiplication gives us quite a nice result there. So that's that question done. Take a look at the next one. So the next one now, we're looking at tree diagrams. So question 11 here. So we've got 9 blue balls, 3 red balls. If we select at random and we don't replace it, so that's important, we don't replace it. And then we pick a second one. So let's try and draw this problem. Do I have enough room up here? No, I'll do it down here. So my first one. So we've got 2 possible options. We can have a blue or we can have a red. We've got 12 balls in total, so this would be 9 out of 12. And this would be 3 out of 12. I wouldn't simplify your fractions here. I just keep it as it is. Okay, so 9 over 12, 3 over 12. If we pick a blue one now, what would we end up with? Well, we don't replace it, so in total now we only have 11 balls. And because we pick one of the blue, there can only be 8 possible blue ones now, so that would be 8 out of 11. And obviously, if you've only picked blue, the red would be unaffected, so that would still be 3. But we have a new total now, that's 11. Okay, so that's blue, that's red. Make sure you label each set of branches. And then if you pick red, well, the blue will be unaffected, so that'll be 9 out of 11. Okay, so that's blue. For the red, well, we took 1 off the red, so that'd be 2 out of 11. Okay, and that's our probability tree there. Good little check is that at each stage, the sum of the branches should be 1. Okay, so 9 over 12 plus 3 over 12, that's 1. 8 over 11 plus 3 over 11 is 1. And then 9 over 11 plus 2 over 11 is 1. If the branches don't sum to 1, so they're either less than 1 or they're greater than 1, then you've definitely made a mistake. They should always sum to 1. Okay? Part B then, we want to find the probability that the second ball selected is red. So, if the second ball selected is red, what we essentially need to end up with then is we either need to arrive at this one here. So in fact, I'll do it in red just to show what we've got. So we either need to end up at this one here, okay, because that one's red, We also need to end up here. Okay, both of them would satisfy that condition that the second ball is red. So how do we get to this one? Well, we've got to go up this branch here and then down this branch here. Okay, so that's 9 over 12 times 3 over 11. So we'll put that in a bracket because we're going to need to multiply two more probabilities here. And again, to get to this red here, I've got to go down this one here and then down this one here. Okay, so that's 3 over 12 times 2 over 11. If you work this out in your calculator, what you should get here is 9 over 54 plus 1 over 22, which is equal to 11 over 44, which would simply just be a quarter there, or 0.25 if you prefer. But yeah, you know, take your time with it. Make sure you're going down the correct branch. Remember, when you're going across the branches, we multiply. Okay, so 9 over 12 times 3 over 11. And then part C, the balls are different colours. So how do we get, basically, what is this question asking for? Well, what it's asking for is that we get one blue, one red, or we get one red, one blue, for example. So, if we change this to a different colour, let's do this one in yellow. So what we're looking for now is that we get one blue, one red. So, for example, if I go across this one, so if we start with a blue one, and then we get a red, I'd have to go down this one. Okay, so we need that one there. So if we write that down, that's 9 over 12 times 3 over 11 again. Okay. Again, we're going to add on because we also can consider getting a red one and then getting blue. So we can go down here for red. And then to get a different one, this would have to be blue. Okay, so that's 3 over 12 times 9 over 11. Plug these into your calculator. And what you should get here is 9 over 22. Okay, and that's it. So I would do this. I like doing this. Just kind of colour the branches in, or highlight the branches that you're going down, and then highlight which point you're going to end up at. So we're ending up at that one, and we're ending up at that one there. Okay. So now we're taking a look at some exam type questions off the old exam papers. So this one here is dealing with Venn diagrams. So we've got actually 3 circles here, which is basically it's modelling these magazines A, B, and C. So the first question, question 4A, we have to show that the probability that the student reads more than one magazine is 1 over 6. So how do we do this? Well, if they read more than one magazine, what that actually means is essentially they're either reading A and B, B and C, or they're reading A, B, and C. Now, given that the circles don't intersect, like for example, something like this, where they don't intersect all 3, we only have the 2 intersections, right? A and B intersect, and B and C intersect. So, due to that fact, we can only have 2 possible outcomes. They read A and B, or they read B and C. So what we care about here is the intersection. So this question, essentially, we get this probability by doing the intersections divided by total number of people. Okay. So if we add the intersections up, what would that give us? So 2 people read A and B, and then 3 people read B and C. So that's 2 plus 3 divided by our total number of people, which is what? So we'll just add up all the numbers. So 4 plus 2 is 6, plus the 5, plus the 3, plus the 6, plus the 10. Add all of them up, we get 30. Okay, so this gives us 5 over 30. And if you simplify this, divide numerator and denominator by 5, you get 1 over 6 as required there. Okay, so a nice question to start off with. Part B now. How do we do this? Well, we're looking for the probability that the student reads A, or B, or both. Okay, so that's the important fact there. Well, essentially, all we actually care about then is the numbers that are in A. So if I change my pen colour, what we care about is anyone in A. That includes this intersection here. Anyone in B. Anyone here. Okay, the only one we don't really care about is 6, right? because that's just for magazine C here. So if we add this up now, so that's going to be 4 plus 2 plus 5 plus 3 divided by the total again, which is 30. So if we add the numerator, 4 plus 2 is 6 plus 5, 11 plus 3 gives us 14 over 30. And if we divide top and bottom by 2, we get 7 over 15. Okay, so again, pretty standard type of question there to give us 7 over 15. And then finally for part C here, there's 1 mark for it. So use this kind of as a guide. If there's only 1 mark, there's going to be less working out than the previous 2. So why is there less working out than the previous 2? Well, if they read both A and C, this is the probability of A intersection C. But if you notice, A and C never actually cross those 2 circles. Okay, so due to the fact that they don't cross, the probability of A intersection C must be 0. In other words, A and C are mutually exclusive. Okay, A and C are mutually exclusive. So if you see 1 mark where it's asking for basically the reading both A and C, there's an intersection there, and there's only 1 mark, more than likely it's going to be equal to 0, and the 2 events will be mutually exclusive. Okay, so that's that question done. Take a look at this next one here, another Venn diagram type question. So let's take a look at what we've got. So we've got these 200 employees that are split up into a few different brackets. So they're either a full-time worker, a part-time worker, or a contractor. And they either walk or they take public transport, I assume. So we want to find the probability of H first. So let's just work out what H is. So H, as we're told, is the event basically of them being a part-time worker. So if we want the probability that they're a part-time worker, all we need to do is add up this value here and this value here and divide it by the total. So we know the total is 200. So essentially my question just boils down to what is 35 plus 75. So we divide by 200 and we just add 35 and 75 together. Do this, you get 110 over 200, which will give you 0.55 if you'd rather write as a decimal. But that's all you've got to do for that one. And then part B here, we'll stick to red, seeing as we've started in it. This one's a bit trickier. We're looking for the probability of the intersection here of F and W. I don't know what that was, let's just get rid of that. So F and W. But then we take the complement. Remember this little dash, this is the complement, okay? So we're taking the complement. So what I'd do here is I'd work out F intersection W and then just take the complement. That would be the easy way to do it. So what's the probability of being F and W? Well, what's F first? So F is a full-time worker and W is that they walk. So how many full-time workers walk? Well, full-time workers that walk, so it's just this value here. So that's 2. So actually, F complement W is 2, but we want the complement of that. So essentially that's just everything but that one. So if you want everything but that one, that's going to be essentially 1 minus 2 over 200. Okay. Work this out. This will give you 198 over 200, which we could write as 0.99. That's one way you can write if you want. Or you can keep it as 190 over 200 if you prefer, but that's all you got to do for that one. And moving on to this very final exam question here, another tree diagram question. So question 1A. So a jar contains 2 red, 1 blue, 1 green. Helps if I read it properly. So we draw 2 beads at random, and we don't replace them. So let's have a go at this one. So for this tree diagram question, I will need a bit more room. We're actually going to have 3 branches now, because we either have red, blue, or green, like so. But then we draw another bead, so we have another 3 branches off each one. So this is where I struggle for room. It's not particularly easy. Okay, that might justify it do. Let's give it a go. So, how many beads do we have in total? We have 2 plus 1 plus 1. So we've got 4 beads in total. So for red, that's 2 out of red. 2 out of red, 2 out of 4. Okay, I think I'm losing the plot. 2 out of 4. We have 1 blue, so that would be 1 out of 4. And 1 green would be 1 out of 4 as well. Okay, again, make sure these branches add up to 1, which they do in this case, so we know we're on the right path. Red, blue, and green again. So let's consider what happens if we pick a red. So if we're on this tree here, then we took a red. So we're only going to have 1 possible red left. We don't replace it, so we only have a total of 3 beads now. So 1 out of 3. We've got 1 blue, and we've only got 3 in total, so this will be a third. And then finally the last one will also be a third. That one was quite nice. So red, blue, and green again. If we take a blue one, well, the reds won't be affected. There'll still be 2, so that's 2 out of 3. If we took a blue one now, this way is kind of just, you've got to be careful here. If you take a blue one, that would leave us with 0 out of 3. Well, 0 out of 3 is just 0. So what I can actually do here is rub out this branch here. Okay? So that's 2 over 3, and this must be just 1 over 3. And finally, red, blue, green. So if we take a green one, red's unaffected, so that's 2 out of 3. Blue will also be unaffected, so that will also be 1 out of 3. And if you notice, these probabilities are already sum to 1. So what we're going to expect here, and clearly it's the case, if you take 1 out of the 1 green, we get 0 greens left, so we can just eliminate that branch there as well. Okay. So that's our probability tree there, quite a long one, but just take your time with it. And then for part B, we're just going to work out a probability from it. So we want to find the probability that a blue bead and a green bead are drawn from the jar. So there's 2 different ways you end up here. If you pick a blue one and a green one, so let's just change the colour so we can see it nice and clear. Let's do it in green. So if you pick a blue and a green, well, I can go across the blue and then down the green. So that's just going to be 1 over 4 times, because we're going across the branches, 1 over 3. Like so. Plus, so that was blue to green. We can also go green to blue. So we're down this branch here, and then across this branch here. Okay, and this will also be 1 over 4 times 1 over 3. Works out when you calculate this is 1 over 12 plus 1 over 12. If you work this out, you get 2 over 12, which is 1 over 6. Okay, and job done there. So that brings us to the end of this video. Quite a lot of questions, but I hope this has been helpful. This is usually one of the more trickiest topics sometimes for certain students. I hope it has helped though. If there is any errors or anything that's unclear, please just leave me a comment down below.